theorem. The intermediate value theorem is an existence theorem. I know that sounds funny, doesn't it? In other words, it says, think about what the intermediate value theorem really says. Do you remember the intermediate value theorem? The intermediate value theorem said, if we have two x values from a to b, right? So if we have an interval from a to b, that if the first value is negative and the second value is positive, in other words, if we plug in f of a and we get a positive value, and then we plug in f of b and we get a negative value, we know that that thing crossed the x-axis, didn't it? Think about it. If we have one value that's positive and the y value that's positive, and the next y value in order is negative, it had to go from positive to negative. It has to go across 0, doesn't it? That's what we've used the intermediate value theorem for. Now, we're going to break this down a little bit more and say, in other words, the intermediate value theorem tells us the existence of a root. Make sense? Why it's called an existence theorem now? Okay? So, what it says is that if we have a continuous function, so there's the first thing, continuous function. F of x is continuous. We can't use this if it's not continuous. All right? And we have some number, we don't care what it is, some x value c. We also know that a and b have to be different numbers. Why do you suppose a and b have to be different numbers? Do we really have an interval if a and b are the same number? No, we're just at a single point, aren't we? So a and b can't be the same, and they can't have the same y value. They have to be different y values. So a cannot equal b, and f of a cannot be equal to f of b. The y values have to be different. If the y values are the same, how do we know if we did anything? It could just be constant. The y values have to be different for us to know that it's moving from one place to another, doesn't it? Okay? If we plug c in, we have to get some other value of y. Now, here's the thing. If c lies somewhere between a and b, so here's a and here's b, and we're going to say c is here. Okay? If c lies somewhere between a and b, then f of c has to lie somewhere between f of a and f of b. That's what it's saying. Okay? In other words, if we take this and we take a and we go up, do you agree that this point right here would be f of a? Yeah? Well, f of b would then be here, wouldn't it? So if c is somewhere between a and b, then f of c has to be somewhere between those two values, doesn't it? Intermediate means middle. So intermediate value theorem says if you've got an x value in the middle of two other x values, then the y value has to be somewhere in the middle of the other two values, the other two y values. So take a look and see. Then c has to be somewhere between, so f of c, so if c is between a and b, then f of c is between f of a and f of b. Intermediate being in between, in the middle of. So this point right here would be the point CK. In other words, this f of c is equal to k. So k is between f of a and f of b. In other words, you can't skip y values. Continuous means you don't skip around, doesn't it? Continuous means it's one smooth curve. Whatever's happening, it's smooth. So if we're smoothly going on a curve, we can't skip around and say, okay, we're going up and now we're over here. If we're going up, we have to continue to go up until we go around. So if this guy's lower than this guy, if we're going up, if we're increasing, then the A and the B mean C's in between, and this is going up. Then the y value has to be somewhere in between as well. Does that make sense to everybody? It just really is saying that between, if you're between A and B, then your y value is between as well. All right. So, let's revisit the homework question. You remember this one from your last homework where it gave you this and said, why can't we use the intermediate value theorem? And everybody was like, I don't know. What's the first rule? On 1, 2, and 3, just above, what was the first rule? The first rule said that it has to be what? Continuous. Guys, is this guy right here continuous? No, not for 1 to 3, is it? We know that this guy has a vertical asymptote, don't we? At x equals what? 2. So we know that x cannot be equal to 2. Well, 2 is somewhere on this interval, isn't it? So what does this mean? It means that h of x is not, not hot, not. So it violated rule 1, didn't it? Now, how do we tell if we have a 0? Do you remember? This is a good review. How do we tell if we have a 0 there? We are looking at the y values, aren't we? What are we looking at? We're given x values and we're given a function. If we have the two x values and we expect it to cross the axis, guys, it is either going to cross the axis going this way, which means our y value is going to go from a negative to a positive, right? Or it's going to go this way, and our y value is going to go from a positive to a negative, isn't it? Because think about it. This is our y equals 0 line. And this is our zeros, isn't it? Isn't that how we tell we have a 0? Is it's an x-intercept, right? So the y value is 0. So what we're looking for is that y value sign change. Okay? So we want to see a y value sign change. So how can we test that? How can we figure out what our y values are? We have a function, and we have two what's? What do those represent, the 0 and the 1? X values. So we have x values. So what we want to look at is f of 0, and we want to look at f of 1. So why don't you guys, and we've got the function there, don't we? So just plug in. Plug your 0 and 1 into that function and see what you get. So did you get negative 1 for f of 0 and 2 for f of 1? So what do you notice? We went from a negative y value to a positive y value. So we've got this scenario, don't we? It's crossing the x-axis. So this sign change We know that f of 0 is less than f of c, which is less than f of 1, right? Those are the y values. So if this lies somewhere between those two, and this is a negative and this is a positive, then c must be where it crosses the x-axis, right? In other words, this is going to be where it's 0. Somewhere in between there, intermediate between the two, it has to cross the x-axis, doesn't it? Which means 0 has to be somewhere between that negative and that positive. You cannot get from a negative number to a positive number without going through 0. That's what the intermediate value theorem says. You're just plugging in for this, guys. It's really just plugging in and seeing that you get a sign change. Now, here's my favorite part. Division. We are going to look at long division and we're going to look at synthetic division. In this class, we will mostly be using synthetic division. I know, a lot of you hate long division. Do you love long division? That's good. It's fun. It really is. Once you get the hang of it, it's easy. But for those of you who hate polynomial long division, I'm going to give you a shortcut that works probably about 90% of the time. So, yay for y'all. All right, so let's remind ourselves of the language of division. All right? When we are dividing, we have the result. We have the thing that's being divided. The thing that is being divided is the dividend. Okay? If we take that and divide it by a quotient, or divide it by a divisor, right, we get a quotient and we get a remainder. So this is my quotient. Thank you. And this is my remainder. Okay? All right, I got 3 of these. Okay. Giselle and Bella and Aurelia. I don't know what. Oh, Bella. Some sort of schedule change. Whoa! What just happened? Okay, so let's remind ourselves of what happens with regular long division. I would like to take 174 and divide it by 4. How do I do that? Inside the little division cap, right? And the 4 goes on the outside. So, to do long division, the first thing we say is, will 4 go into 1? We take the biggest, divide it by, no, it won't. So then we move over some, don't we? We kind of drop it to the next one. Will 4 go into 17? Okay, so we're literally saying 17 divided by 4 goes how many times? 4 and some change. We won't worry about the change, but we know it goes 4 times. So that 4 right there, this 4 ends up going here, doesn't it? Now what do? Yeah, we multiply, don't we? So 4 times 4 is, and then what do? We subtract. So sign changes, 17 minus 16 is 1. And then we bring down. And we start this all over again, don't we? Now we take 14 and say, how many times will 4 go into 14? 3 times, won't it? So this 3 right here goes here next to that 4. And we continue again. We say 3 times 4 this time is what? And we subtract. 14 minus 12 is, and that is a remainder, isn't it? So we know the answer to this is actually 43 and 2 over 4, right? Yes? Or what we could say is this is the same as saying 43 times 4 plus 2. That's what this is saying right here. This is my Q of X. This is my D, my divisor. We're dividing by 4. And then the remainder is here. You see how we can write this as the quotient times the divisor plus the remainder gives us that number back, doesn't it? I bet if you put in your calculator 43 times 4 plus 2, you would get 174. Okay? Now, we can apply the same technique, but to variable expressions, to polynomials. Same idea, guys. How many times will it go in? Figure it out. Put it up top, multiply, subtract, bring down, start all over again. It really is just that easy. Now, I'm going to show it to you in long division, and then I'm going to show you the shortcut so you can compare them. So this time, we are taking 5x squared minus 17x minus 12, and that goes up underneath, doesn't it? What are we dividing by? So that's what goes on the outside. Now the cool thing is that we only have to do biggest divided by biggest this time. So we are going to take this biggest and divide it by that. And I'm just going to go straight over here and say, all right, 5x squared divided by x. How many times will x go into 5x squared? Just simplify that expression. If you had to simplify that, 5x squared over x, what would you get? Yeah, 5x. So you would get 5x. Well, guess what? That goes here. Now, why did I put it over the 17x instead of the 5x squared? The degree matches, doesn't it? Now, we do the same thing we would do if we were doing number long division. We're going to now multiply, aren't we? So we're going to take this, and we are going to multiply. What will we get? 5x squared minus 5x times 4. But we have to do what? What did we do previously? Subtracted. So we have to change this. Subtracting is the same as changing the signs, isn't it? So we can change the signs and add. So what happens to the 5x squareds? They cancel out. Guess what? They better. And now we have negative 17x plus 20x. Which is what? 3x. And now we have to bring down. And guess what? We start the whole thing all over again. We are now going to take this, is now the biggest term, isn't it? And divide it by this. So we are going to take 3x and divide it by x and tell me what we get. If we simplify 3x over x, we get 3, don't we? Is that 3 positive or negative? Positive, so it ends up as a positive 3, so it's plus 3. Now guess what we do? We are now going to take this and multiply. 3 times x. 3 times negative 4. And we're going to subtract. What do we do to subtract? We simply change the signs and add, don't we? So this becomes a negative, and the negative becomes a... So what happens to both of these terms? So what is my remainder here? 0. So when we rewrite this, guys, we know that 5x squared minus 17x minus 12 is actually equal to, what did we end up with up here? Times the divisor, which is and then plus the remainder. Is there a remainder? So we don't put plus 0, we just leave it, boom. You know what we've just done here? We've just factored that. We've just found if we know one factor, we can now use division to find the other factor. Make sense? Some of you may actually begin to like this. Now, I know for some of you, you're like, I don't like this. Can you show me the shortcut, please? Yeah, I can see some of you in your face. You're like, yeah, I want a shortcut. All right, so let's do the shortcut here. Synthetic division. Synthetic division takes all those pesky x's away. Now, there are some rules for synthetic division. Synthetic division says you have to have every power present from the highest to the lowest. So the first thing we have to check is we've got x squared, x to the first, and then x to the 0, don't we? So we're covered there. So what we do next is we take the numbers in front of those and we list them. We take our 5, our -17, and our -12. If we are missing one of those powers, we fill in the appropriate spot with 0. And you'll see that later in the lesson. We'll be missing something and we'll have to put a 0 in. We're going to do our division symbol upside down. Instead of over the top, it goes under the bottom. Leave space under there. Now, what goes on the outside is not all of x minus 4. Remember, we're just dealing with the numbers now, aren't we? We just want the 0. So how do I find the 0 from x minus 4? And solve. So what is actually x? 4. So that's what goes out here. This guy, make yourself a note. This is the 0, not the factor. If you're doing long division, you put the factor. If you're doing synthetic division, you've just put the 0. Okay? So that's this guy right here. Now, watch how fast this goes. Didn't take long to get it set up, did it? First number always comes straight down. And then what we would normally do with regular division, we multiply across the diagonal. So we're going to multiply. What is 4 times 5? And then we add straight down. We don't even change the sign. -17 plus 20 is what? 3. And then we do the same thing all over again. We multiply across the diagonal. 4 times 3 is what? 12. And then we add straight down, and what do we get? That last piece is always the remainder. Now, we knew we had a 0 remainder, didn't we? Because, guys, we just did the same problem twice. And I want you to look at something. Look at what just happened here. Notice what's up here. And notice what's here. What do you notice about those? It's the same. What's the only thing that's missing? We just got to put the x back in. Do you know how I know what degree that's going to be? Why it's just going to be an x? We started with an x squared, didn't we? And when we divide by an x, don't we go down by 1 degree? So what's 1 degree below x squared? X. This is what we call, weirdly enough, this is what we call a depressed polynomial. Not like, you know, gonna jump off the roof, but depressed is in down a degree. Okay? Depressed polynomial. So that 3 becomes 5x plus 3. Boom! Which method do you like better, long division or synthetic division? Yeah, synthetic's faster, isn't it? Now, when can we use synthetic and when do we have to use long division? We can use synthetic as long as there is only a 1 in front of this. If it's just a plain x, if there is a number in front of that x, we cannot use synthetic division. So we can always use synthetic division No, there's not going to be any coefficient in front. And you can't have an x squared, an x cubed, etc. It has to be x to the first power and no coefficient in front of it. If you have an x squared, an x cubed you're dividing by, if you have a 2x or a 3x or a negative 5x, guess what? You have to use polynomial long division. Now, lucky for you, we're pretty much mostly just going to be looking for roots, so we're just going to be using synthetic division for the most part, which is why I'm teaching this to you. Synthetic division is fast, so let's do this. We use synthetic division in two cases mostly. We use it with the remainder theorem. That remainder, believe it or not, how many of you make mistakes when you substitute numbers into a polynomial? You're more prone to make mistakes, aren't you? Sign mistakes and stuff like that? Yeah. Believe it or not, synthetic division keeps you from having to do that. Synthetic division is the same thing as substituting a value in. So if we know a value, if we know that something is divided by x minus h or x minus k, then the remainder r is the same as if you plugged in k. Now, what on earth do I mean by that? Well, let's look. I'm going to come back. How do we find a factor? How do we verify a factor? A factor, what's another word for a factor? What do factors become? Give us zeros. What's another name for a zero? What type of intercept is a zero? No, it's an x-intercept. So if it's an x-intercept, what's the y value there? If it's an x-intercept, it's a point on the x-axis. So the y is 0. And remember what we just said? We just said the remainder theorem says if you plug in, you get the y value out, don't you? The remainder is the y value. So if we're plugging in a 0 or we're plugging in a root, what should the y value that we get out be? 0, which means the remainder ought to be what? 0. That's how we tell if something is a factor. If we run it through synthetic division and the remainder is 0. That's what this means. It says if f of k is 0, then x minus k is a factor. If x minus k is a factor of f, then the remainder equals 0, doesn't it? Or f of k equals 0, right? That's the same thing. So now, this is a chance for you to practice some synthetic division and get good at it. Let's skip to the next page so you can see what I'm talking about. Here we go. Use the remainder theorem to evaluate f of x when x equals 5. So in other words, normally you would say, all right, I want to find f of 5. Which means I have to plug in here and here, don't I? You don't have to do that. You can, believe it or not, it's actually faster if you use synthetic division. So if we want to set up synthetic division, we got x squared, we got x to the 0. So we got all the powers, don't we? So what numbers go across the top there? 4, negative 10, and, yeah, you got to include the signs. No, it's cool. We're all learning. Now, what number goes on the outside? 5, because it's already in the x equals, isn't it? So now, you want to try it on your own? What happens to the first number? Straight down. Okay. What do we always do diagonally? Like this is diagonally, isn't it? What do we always do? What operation do we always do diagonally? Multiply. And where does that go? Yeah. So what goes under the negative 10? Okay. So now what do we always do straight down? Add. So what do we end up with there? And now we're going to do the diagonal thing again. So where does that go? Okay, so what goes under negative 21? And so what do we end up with? 29. So guess what f of 5 is? 29. Guys, this is the same as if we had done 4 times 5 squared minus 10 times 5 minus 21. By the time you write that down and plug all that with parentheses into your calculator and hit enter, you could have done it using synthetic division, probably faster and more accurately, okay? Or at least as accurately in your head, okay? Do you see how this works? So if we want to know by substitution what something is, then we can run it through synthetic division and find it. That's the remainder theorem. The remainder is as though you substituted that number into the function. Okay? Get it? The remainder is the value that you get if you sub in. Okay. Now, how do we... in example 6, it says, is x plus 3 a factor? So we need to run it through this using synthetic division. But what are we running through it? Negative 3. If it's in factor form, this was not in factor form. This was a 0 form, isn't it? If it's in 0 form, it just comes out here. But if it's in a factor form, we got to find the 0, don't we? So what is the 0 if it's x plus 3 is the factor? Negative. It comes out opposite, doesn't it? So put your negative 3 on the outside, set up your synthetic division, and see what the remainder is. So what goes across the top there?
3.
All right, so run it through. See what you get.
The last one's always the remainder.
Yeah, sure is. Okay, so what did you get for a remainder? Okay, we come down 3, negative 9, negative 5, positive 15, negative 3, positive 9, 6, yep. See how fast that goes? It's just numbers in your head. So, answer the question. Is x plus 3 a factor? The answer is no. Now the explain is the remainder is not equal to 0. For it to be a 0, f of negative 3 would have to equal 0, wouldn't it? And it doesn't. It equals 6. Okay? Now, here's a fun one. It says verify that x plus 3 and x minus 2 are factors. Well, here's a fun one. Let's do this one. This is kind of cool because you can stack synthetic division, unlike regular long division. So let's start with the first one right here. X plus 3. What goes on the outside? We're going to test and see if this is a factor. We want to verify it. So negative 3 goes on the outside. What goes across the top? 3, 2, negative 19, and 6. All right, run that through synthetic division. What should you, if you're verifying that it's a root, what should you be looking for as a remainder? You're looking for 0. Sure enough. Did we get 0? Yeah. Now, here's the cool part. I now need to check x minus 2, but I don't have to rewrite it. I've already factored out x plus 3, so guess what I can do? And this is where it comes in handy. I can now take this guy and put it through what's left. Isn't that nice? So now how do we verify that 2? X minus 2 is a factor. We're still looking for a remainder of 0. And look. I love synthetic division. It's so handy and it's so easy. And look what's left right here is the last remaining factor. We know this is a cubic, so how many zeros should it have? Well, it's cubic, so it should have 3, shouldn't it? Well, we got 1, 2 there, and guess what's going to show up for the last one? That's linear at the bottom, isn't it? That's a linear factor, because that's 2 orders down. We started with the cubic. We went from, this is what I'm talking about. Remember that depressed polynomial thing? This is to the 3rd power, so this must be to the, and then we're going to depress again, and this must be to the 1st. So guess what? That's a linear factor. How would we rewrite this? 3x minus 1. Oh, yeah. So guess what? This polynomial right here, this f of x, is now equal to x plus 3 times x minus 2 times 3x minus 1. Because that's what this is. Now, if we want to find the zeros, what's the 0 from x plus 3? Negative 3. What's the 0 from x minus 2? What's the 0 from 3x minus 1? You can do this in your head. Change this to positive, right? So positive 1 divided by 3. So it's going to be positive 1/3. So use those tricks to do them in your head. So the third one's going to be 1/3. Isn't that just way easier than having to try to figure out? Yeah, okay. It really is. Now, if we're given factors already, it becomes easier to find other factors. What happens if we start with not having any of those factors given to us? Can we find possible factors to test? And the answer is yes. This is where the real pre-cal / calculus starts to come into play here, guys. We're setting you up to be able to factor anything. Rational zero theorem, okay? Rational means fraction, okay? Possible rational are going to be factors of the constant term divided by factors of the leading coefficient, P over Q. You'll hear me say that a lot. Let's find our P over Q's. So this is going to be factors of the constant term, factors of the leading coefficient, okay? And this is for anything that is greater than or equal to 1. In other words, if it's linear or beyond. The factors of the constant term are your p's. The factors of the leading coefficient are your q's. Possible factors of the entire polynomial come from a combination of those. Okay? So let's look. Here are the rules for using the rational root theorem. First thing it says is find one root using synthetic division. Then we continue to find roots and dividing and notice what you're using the whole time is synthetic division. You don't have to worry about long division here, just synthetic division. Continue finding roots until you have a second degree polynomial. Once you have a second degree polynomial, you usually stop because then we can either factor it, complete the square, or use the quadratic formula. One of the three. So you have three things, three ways. Any method could be any of those. Typically, we try factoring first, and if it won't factor, then we just jump straight to the quadratic formula. Okay? All right. So now, let's do our P over Q's here. So P's right here come from the constant, doesn't it? So our P's are going to be factors of 6. What are our factors of 6? What are any possible factors of 6? That means what can I multiply to get 6? 1 and 6. So plus or minus 1, plus or minus 6. And what else? 2 times 3. Now, why are we doing plus or minus? Because we could multiply a positive and a negative or divide a positive and a negative to get negative 6, couldn't we? We always do plus or minus in front. Now, Q's come from the lead coefficient. What is the implied lead coefficient right here? 1. So my Q's are going to be, what are the only factors of 1? So this is going to be plus or minus 1. Now, we are going to take every P that's possible and divide it by every possible Q. This one's easy because it's always easy when the Q is just 1. When the lead coefficient is 1, you're going to be like, woohoo! They're going to be not too bad. When the lead coefficient is not 1, then it gets to be fun. So all the P's, so we're going to do plus or minus 1 divided by 1. So we're going to do, what's 1 divided by 1? So my P over Q's are going to be plus or minus 1. And then I have to do 6 divided by 1, right? This P over Q. What's 6 divided by 1? See what I mean about if Q is 1, it's nice and easy. And then we're going to do 2 divided by 1, right? P over Q. So this will be plus or minus 2. And then 3 divided by 1. Okay. Now, we have to test these until we get it down to a quadratic, which means this is a cubic. So really all we're looking for is one that works, aren't we? We're looking for one single one that works. So we're just going to start at the beginning of the list, which is -1, right? +1, -1. Let's start with +1. So we're going to start with 1 here. Now, this one's fun because look what we're talking about. Remember what I said about you have to have every single degree? Do you see this f of x? What are we missing in this f of x? Which degree term are we missing? So we have to put in a plus 0x squared here to have all of the terms, don't we? Now, why did I put that in there? Because I have to put my numbers across the top, don't I? So what are my numbers going to be across the top? 0, -7, -6. If I don't do that, then I'm going to screw it up. You can't forget the missing terms. So now let's very quickly do this. Bring down 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -7 plus 1 is -6. 1 times -6 is -6. And this is not 0, is it? So is 1 a factor? Nope. So guess what? We go to the next one. -1. 1, 0, -7, -6. And we start all over again. Isn't it good that this is fast? Because until we find one that works. Well, let's see. We might get lucky. This is 1. Negative 1 times 1 is negative 1. Add negative 1. Negative 1 times negative 1 is 1. Negative 6. Ooh, hey, guess what? We're getting lucky. Negative 1 times negative 6 is bing. Have we found a 0? Yes. That means that one of my factors is x plus 1. That's becoming x plus 1, isn't it? And then the depressed polynomial that's left, there are 3 terms here. It goes from a cubic to what? A square, right? Quadratic? So how is 1 minus 1 negative 6 going to be written as? Minus x. Now, remember what it says? Find one root. We did that. Continue until we have a second degree polynomial. Do we have a second degree polynomial? Now it says factor if you can. Can we factor x squared minus x minus 6? Well, let's go over here and see. Negative 6 in the top, negative 1 in the bottom. 2 factors that multiply to give me negative 6 that add up to negative 1. Negative 3, positive 2, right? So look, x plus 1 becomes x minus 3 and guess what, guys? That is my factored form, isn't it? Is that my zeros?